So now we are going to look at branching instructions. For what purpose are we using branching instructions? See, we need, if some of you might have studied C language, we need loopings, we need loops, okay. So that we do not have to write big programs. To short our programs, if a single thing has to be done a lot of times, we are using loops. So for the purpose of making loops, we are using these branching instructions. What they are going to do is, they are like jump instructions. What they are going to do, that if you are at a particular address and you want to jump to another address which is not immediate next address, then we are using these instructions, jump instructions. So we are having two types of jump instruction, two type of branching instructions. First is unconditional jump. Unconditional jump. So the instruction that we are using is JMP, and we are giving a 16-bit address, whatever address you want to jump to, you are giving the address JMP 3070 suppose. So this is the instruction. It is a 3-byte long instruction. 1 byte you are storing the opcode, then 2 bytes are required for storing the address. So this is a 3-byte long instruction. Size of the instruction is 3 byte. Then it is having 3 machine cycles. First machine cycle is going to be opcode fetch of 4 T states. Then we are having 2 memory read cycles for reading the address. Memory read. So this is the total length of this instruction is going to be 10 T states. Opcode fetch is going to take 4 T states. Memory read 3 T states each. So this jump instruction, what it is going to do is, let us look at it with an example. Suppose we are having a program starting from memory location. Let us suppose 2001. We are having a program starting from this memory location. First instruction was XOR A. Then we have, this is a 1-byte instruction. So next instruction is going to be saved at immediate next memory location. Next instruction was INR A. Then we had again INR A. Next memory location had an instruction JMP 2006. Suppose JMP, okay, not 2006, let us say 2009. Now this is a 3-byte long instruction. So next instruction is going to be saved at memory location 2007. Suppose this had the instruction DCRA. Then we had some instruction, say complement A, something like that. And at 2009 you had INR A, and then you had, finally you had halt. Halt means end of the program. So what happens actually in this program is, XOR A means A is XORed with its own content. So contents of A is going to be 0, 0. After execution of this instruction, value of A is going to increment. So A is going to be 0, 1. Again we are incrementing A. So A is going to be 1, 0, which is 2. Now what happens when we reach this instruction, this jump instruction, 2007 and 2008 are not going to be executed, Simply PC program counter is going to be overwritten with this value. Actually what had to happen, after execution of this instruction 2004, we had to go to next memory location, which was 2007. But because this instruction JMP 2009 came, PC value will get overwritten with 2009 and will directly jump to the memory location 2009, which has INR A. So A will get incremented and become 1, 1. So final value of A is going to be 1, 1 after execution of this program. These two instructions are not executed. If they would have been executed, suppose this instruction had been executed, after this value of A should have been 0, 1, and after CMA means complement accumulator. If complement accumulator would have been executed, the content of accumulator would have been FE. Complement of 0, 1 is FE. but this did not happen because these two instructions were not executed since we had a unconditional jump. Unconditional jump means whenever this JMP 2009 JMP some 16-bit address is going to come, no instruction in between is going to be executed. You are going to jump finally to the value given by this address. So this is what is happening in unconditional jump. It is a 3-byte long instruction. Size of this instruction is 3 bytes and is having 3 machine cycles, opcode fetch and 2 memory read. Then we are having conditional jump. Conditional jump. See, we know that the 8085 microprocessor is having 5 flags. Right, we've already studied about the 5 flags. So based on those flags only, we are having conditional jumps. What happens in conditional jump? So we had sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. So we are not having any jump instruction for this auxiliary carry flag. We are not having any jump instruction for this, but we are having jump instruction based on sign, zero, parity and carry. We are having jump instruction based on this. So we are having suppose for sign flag we are having 2 instructions, jump on plus and jump on minus. So let us look at jump on plus first. Suppose I give an instruction jump on plus 2050. So what happens is we are going to check for the sign flag. We are going to check the sign flag. If this sign flag is 1, if this sign flag is 1, which means it is negative number, we are not going to jump, no jump. Okay, simply next instruction is going to be executed. But if the sign flag is 0, means the result is positive, then we are going to jump to 2050. We are going to jump to this location, right? So this is how conditional jump is going to work. Okay, this is the based on sign flag. We are having two conditional jump instruction, which is jump on plus. This stands for jump on plus. And one more instruction we are having JM, which is jump on minus. Okay, similarly similar to this instruction, if the sign flag is 0, we are not going to jump, but if the sign flag is 1, that is if the result is negative number, if there is a minus sign present, we are going to jump to this memory location. Based on 0, we are having two instructions. Jump on 0 and jump on 0, 16-bit address is going to be present here. And second is jump on not 0. So this jump on not 0, we are using this widely. We are using this a lot in the programming, jump on not 0. So here what we are going to do is we are just going to check the 0 flag. We are going to check the status of 0 flag. If the 0 flag is not 1, that is if the result is not 0, we are going to make the jump. Right, so these are the two instructions based on 0 flag. Based on parity flag, we are having two instructions. Jump on parity even and jump on parity odd. Okay, if parity is even, then you make a jump here, and if the parity is odd, you are going to jump here to the required address. And based on carry flag also, jump on carry, jump on non-carry. So here you are going to jump when carry flag is 1, and here we are going to jump when carry flag is 0. Okay, we can just write the status of flags according to which here carry flag should be 1 for jump to happen, here carry flag should be 0, here parity flag is going to be 1, here parity is going to be 0, here 0 flag should be 1, 0, and this is plus minus, so this is S should be 0 and here S should be 1. So this is how conditional jump is working. So conditional jump is also going to be a 3 byte long instruction. In 1 byte we are going to store the opcode, and in the next 2 bytes we are going to store the address. So this is also a 3 byte long instruction. 3 byte long instruction. We are also going to look at its machine cycles. So already we have seen that unconditional jump had 10 t states, it had 3 machine cycles. Conditional jump is not the same. Why is it not the same? Because here we need to check the condition, we need to check the flags if the jump has to be made or not, and checking the condition requires 2 t states. It is a 2 t states long process. So what happens is, if we talk about the machine cycles, what happens is, you are going to make opcode fetch. This has to happen, this is confirmed. Opcode fetch is going to take 4 t states. Next what happens is, we are going to make memory read. After opcode fetch only you are going to know that this is a conditional jump. After this only you can check the condition. So what does the microprocessor do to save time? In order to save time, we do not stop and check the condition. We are going to make memory read for the lower bits of the address first. Meanwhile condition is checked. Meanwhile condition is checked. Checking the condition requires 2 t states. So when one memory read cycle is going on, condition is being checked. Now suppose condition is true. Condition is true. Suppose you had to make a jump if parity was even, and you found that condition is true, that is parity was even. So if condition is true, you are going to have one more memory read cycle of 3 t states, and this is going to be similar to unconditional jump and will take up a total of 10 t states. Suppose condition was false. If condition was false, we are going to stop it here itself. So this is going to take 7 t states. This is going to take 7 t states. So if condition is false, the unconditional jump is going to be a 7 t states long instruction. If the condition is true, it's going to take 10 t states. Checking condition requires 2 t states to avoid wastage of time in case of true condition. See, if condition is false, this is going to take 6 t states only. But if the condition was true, this would have taken 12 t states. So best case is to check condition while you are doing first memory read cycle. One more thing that you can note here is, suppose there is an instruction like this, JMP 2060. So how is it stored in the memory? You can just have a look. Suppose this instruction started from memory location 3000. So at memory location 3000 you are going to store the opcode JMP. This is going to be stored at memory location 3000. Now one thing, since this is a 3 byte long instruction, it's going to take 3 memory locations, 3000, 3001 and 3002. One thing that you can note here is, this is 1 byte of instruction, next 2 bytes are the address. One thing that you can always remember is, higher bits of the address are stored in higher memory location. Lower bits of the address are stored in lower memory location. That is, when we are storing this instruction, you are going to store 60 first, and next you are going to store 20. Here you are going to have 60 and here we are going to have 20. Lower bits of the address are stored in lower memory location. 3001 is lower than 3002. So lower bits of the address we are going to store in lower memory location, higher bits of the address in higher memory location. So this memory read cycle will be for 60. First we are reading the memory address, lower bits 60, and if condition is true you are going to read 20. You can just remember this thing. This can help you sometimes when you study stack. You'll understand this, the importance of this thing. For now you can just note this memory machine cycles of conditional jump are going to be 70 if the condition is false and 10t if the condition is true. Now we are going to look at some looping and timing delay modules.